Hello and welcome to this talk about using API specifications as executable contracts to mock and test microservices. My name is Krishnan. I'm a co-founder and the CTO of Specmatic. I also help with transformation advisory. I'm a coach and a trainer and an API governance strategist. I love conferences and communities. Here are some of the conferences I've spoken at, and I also volunteer at quite a few of them. AsyncAPI conference happens to be one of my favorites, and I'm really glad to be part of it again this year. So that's quickly about myself. Let's jump right into the topic for today. So we're going to be looking at an order service which is designed to interact with a few topics which are on a Google PubSub cloud. So let's say we have this place order topic on which if we drop a message with order details, then the order service picks up those order details and verifies inventory and whatnot, etc. And then drops a message further onto the process order once it considers that the order is ready to be further processed, which other systems such as a fulfillment service, etc. could take over. Also, it drops messages onto notifications so that services such as SMS or email could kick in and appropriately act on these messages. Now, how does one interact with such an order service? So as a client, I can drop messages into the place order, and once the processing of that particular order is done, I could await for messages on topics such as the process order and notification. That is how I interact with such a service which is exposing these capabilities. Now, let's look at how to go about testing this application. Typically, if I have to test such a service, I would have to hand code a bunch of a client which is going to drop a message onto the Google PubSub topic. Then I also need to await on the messages and verify if those messages are according to what I expect. Now, all of this would be a handwritten code, and of course, when you have to write code, custom code for something, it also comes with the maintenance overhead. As the API evolves, we need to constantly upkeep this particular test, which is not going to be when we're hard pressed for time. That's not the most that may not be the best use of our time also, right? Of course, while it's important, we do have other aspects to take care of. So how can we solve this problem? So let's take a look. Let's say order service is our system under test. Then first order of business is to make sure that I can get it running on my local machine. I don't want to be dependent on a complex staging or some hosted environment where Google PubSub is running. So what I can do is PubSub gives me emulator which I can boot up locally on my Docker, and that's beautiful because then I don't have to depend on any other environment where Google PubSub is deployed or available to connect. So all I do is directly start the emulator on my local machine, and let's say these topics are available here. Then I would configure this order service to talk to this local emulator. Once I'm done with that, then I need a test, right? And here's where I was testing. I don't want to write these tests by hand. So that's where Specmatic as a tool comes in. The Specmatic Google PubSub capability leverages the AsyncAPI specification, which is describing the interface that is exposed by the order service, and uses that in order to generate contract tests. And basis that, it is able to send messages to the place order topic, because obviously the topic would be described in the AsyncAPI specification. And once the order service receives such a message, what it is going to do. It is going to process it, and it's going to drop the appropriate messages onto process order and notification. And because the AsyncAPI spec would also contain details about where the responses or as a result the messages arrive are also available. Now the Specmatic is also able to understand where to await for those messages and verify whether you got the right kind of messages and the number of messages on the appropriate topics, and those messages that we received, are they according to the schema that we have defined in the specification. Now that seems like wonderful, right? Because all I'm claiming here is all you need is an AsyncAPI specification, and you don't even need to write the test, and the test will probably just directly taken care of. And the beauty of it is, as the API evolves, the AsyncAPI spec will automatically update it, and thereby the tests automatically get updated themselves, because it's all a dynamically generated test, right? Now you don't have to take my word for it. Let's look at a quick live demo of how this can be achieved. So jumping right into my IDE, and here's my contract test which I was talking about. Let's give a quick walkthrough of what we're doing here. So first things first, you notice my contract test is going off of the Specmatic Google PubSub test base. So that's the starting point. And you'll notice that I have only a setup and a teardown and no tests in between. Of course, before that, I have this small little utility called Google PubSub emulator. Now this emulator itself, just to give you a quick walkthrough, is using test containers here, because test containers again is a very, very useful project we have seen in terms of being able to spin up environments quickly and kill them. So all I'm doing here is starting the Google PubSub emulator on my Docker, and I have some utility pieces written here just to make my testing easier. So once my PubSub emulator is set up here, which means I have a completely viable Google PubSub available locally on my machine, and I can use it for my testing purposes. Now let's look at the setup. The setup has nothing major in it. It is just about starting the application, and also the teardown has like verifications and stopping the application, and of course stopping the emulator. Now that's pretty much it. Let's give this a quick run and let's see what happens. Now this is obviously going to create in our Docker the emulator, and within that emulator this whole application layout is going to be set up and verified. And even before we could finish describing what happened, a test has already been run. Now let's understand what just happened, right? Now first of all, what is this test that's going on here? How did this even come about? Like I said, I only have a setup and a teardown, no tests in between. Where did all the tests come from then? At least this one test. This test, how did it come about? That is described in the specmatic.yaml, a configuration file. The first two lines here which you see are the location from where to fetch the AsyncAPI specification. I'm saying that here is a Git, the source is a Git repository, and this is the URL to the Git repository. And now from that Git repository, I specifically want to look at this API specification. That's the coordinate I'm providing it, and here is the API specification. Now basis this, Specmatic is pulling the AsyncAPI specification from the Git repository and using it to run the test. Now let's further jump into what is going on, what are the topics and the details of the AsyncAPI specification itself. So I've taken the same spec and loaded it up into the studio, so it's more visibly like you can see what's going on. As you can see, this is an exact representation of the image that we saw earlier, which is it has a place order topic, the order service, and it has two other topics, process order and notification, on which you have subscribed. So it says publish. Again, this is AsyncAPI 2.6, which is why you see a publish on place order and a subscribe, which means listen on this, right? So now that's the very basic detail. Now let's look at what happened in the test itself. So here it says new order sent, that's the test. So let's look at the details here, and I will look for the word await, and you can see that Specmatic is awaiting for messages on process order. Once that is done, it is awaiting for notification. So those are the two things, right, where the responses have to come. Now also you will notice that it is receiving messages on the place order topic, of course, and it's also receiving messages on the process order topic and the notification topic, right? Well, that's the very gist of what just happened. But for this to happen, I should have first sent a message to the order service itself, right? Where did that happen? That's happening right here. The first line here says Specmatic has published a message on the place order topic, which is where the order service is listening on. Now, how did it know that I have to send an order with this order details, right? One MacBook, one iPhone, this is the quantity, these are the order details. Where did it get the payload or the test data for this particular message that it has to send? Again, look no further, it is the AsyncAPI spec itself. If you notice the place order topic, there is a payload under the example, which is the data that you're seeing. So basically what we've done is the examples in the API specification have been leveraged as the test data message for the message that we have pushed out into the order service. Fine, that's great. Now once that is done, it is awaiting for the results on process order topic, right? Like what we saw earlier. How does it know that I need to await on this particular topic and also on the notification? And once it receives, what to do with it? So that's the beauty of it, right? Now the second part to explain that is, if you notice, the name of this example which we said on the place order topic was called new order. Now let's see what happens further down. So let's look at the process order topic and look at the payload, and you can see that this also has the name called new order, right? And likewise, the notification here also has the same example name called new order. Now because of this, Specmatic is able to smartly string together the relationship between the publish and the subscribe topics, that this message put here would result in responses, or rather messages appearing on the subscribe topics. So thereby it is able to understand and figure out that this is the test scenario. If I drop a message here, then I can expect messages to come back here. Now that's it. This is AsyncAPI 2.6, so we are having to go through with this sort of a convention based approach. But in AsyncAPI 3, of course, you will be able to leverage the request reply pattern, which is natively built into that as a capability. That's for request reply topics. In this case, there is also the nuance that for a single message, you can have multiple messages that are resulting, which is more like a fan out pattern, right? So that's what we're trying to explain here. Now, basis this, Specmatic has sent out one message and waiting for the messages to appear on the subscribe topics, right? Now, what happens later? We can do a lot more, right? Because for these messages, we have payload structures, not just the payload examples. We have the payload schema as to what is the order request, the total amount, like whether it's a number or a string, and the status, like all of this is all again set up here. Now, Specmatic is again going to make sure that the messages that are coming back on these topics are also according to the API specification. Now, again, you don't have to take my word for it. So let's say I'm a new developer on the team, and I somehow did not agree with this whole idea that it's a total amount. So I'm just going to change that to total because it feels descriptive enough to me. It doesn't make sense to say total amount. And maybe I also don't like this whole constant which someone is using. So I will just say processed successfully. So I have updated my code, and I, for some reason, have not really bothered to look at the API specification. I did not realize maybe that there is an AsyncAPI specification governing the implementation of this particular service. So I have gone ahead and make the change. Completely acceptable, I guess, because it's my first few days on the job. I would probably make some innocent mistakes like this, I guess. But nevertheless, let's see if I get some feedback. So I'm going to run the test again, and let's see what happens. And I'd also reckon, for those listening in, please take a guess as to what would potentially happen. And as you can see, the tests are running, and we have failed the test. Let's see what is happening here. So there are a few errors here. Let's go one by one. First one, it says expected key name total amount was missing, but instead I received a key total, which I did not expect. Now this makes sense, right? Because if you look at the API spec, I'm looking for total amount. Total is not there, so my innocent change there to say renaming, refactoring whatever I did is not a good idea. So I should have studied the AsyncAPI spec first, but I guess it's okay because I have the feedback now. That's brilliant. So now I can go and fix my issues. Second, you can also see that when there is an enum, it's absolutely giving me the right feedback. These are the only possible values. You cannot have some other arbitrary strings. Again, this is really, really useful, right? Now, because of such quick feedback right on my local machine, I don't have to be on the CI wall of shame with a broken build, right? I don't want to go there and then realize, oh shit, I have broken the build, and then I have to come back and fix everything, right? Instead, I have feedback right here. I fix it. I don't bother my team. I can quickly fix all of this on my local machine, have a green right on my local, and then I can move forward. So let me quickly revert this change and go ahead and roll back. And the moment I do that, I can run the test again. Now notice how cheap and how effortless this is. When I say cheap, it is literally zero cost for me to keep making changes and running the test. Number one, it's really fast feedback. Number two, I'm not having to write the test. And the beauty of it is the tests which are being generated, they are not being stored anywhere. It's completely dynamic, right? Which is, there is a reason we do that. The reason being that if the tests are something that we are generating, and if we have to check that in, that becomes the second source of truth, which can again deviate from what is the specification, right? We want everything to be driven off of the AsyncAPI specification, so that as the spec evolves, as the API design evolves, the tests automatically update themselves, which means we don't have to actually worry about going and changing them often. So that's the beauty of this whole process. So far we've seen how we can leverage API specification as an executable contract, and especially in the demo, so far we saw the use of AsyncAPI spec in the context of Google PubSub. Of course, when you are using AsyncAPI spec, you can use other protocols such as Kafka, and also if you're using specifications as OpenAPI or Google GraphQL, SDL files or gRPC proto files, even those specifications can be leveraged in a similar manner, right? Sync or async. Now, given the principles are the same, which is basically to be able to take an API spec and convert them into tests and stubs, what can we do with this apart from the clear advantages that we saw for that a developer has? What are the bigger, what is the bigger picture here? So that's mainly where we started with, our goal of being able to try and achieve API design first. For example, if we have like API consumers and API providers, as in like basically teams which are on both sides of the API boundary, and of course architects and application security experts, all of them, we jointly come together to agree on how we should be building application. But more often than not, these agreements, while they're great, are captured in non-standard formats such as email or, for that matter, wiki pages and so on. While they're great, they are not necessarily actionable or enforceable, so to speak. And that's where it will be very useful if you're able to capture these discussions in terms of standard API specifications such as OpenAPI, AsyncAPI, etc. Now, once we have it captured in an unambiguous format such as these, then these are machine parsable, of course, which means, as you saw, we could leverage them as contract tests and for testing or mocking, and that means the API specifications can now govern how applications are built and how they interact with each other. This is really important because in the larger scheme of things, if we can start with the API design first, then we can use that as a single source of truth for our entire development process here on out. Now, what do I mean by treating the API specification as a single source of truth? All parties who are especially like the developers, the architects and application security experts, like what we discussed, should all be referring a single source for this particular spec. And what better place to keep it than a Git repository, right? Because most of us are already familiar with the workflows of working with Git. Pull request mechanism is something that we all are all too familiar with in terms of how to push it into an API, into a Git repository. If you may recall from my earlier demo, I was also pulling the AsyncAPI specification from a Git repository. Now, this is why I was doing it, because even for that application, when I'm building it, I am trying to take the source of truth as the Git repository, because I don't want my local version of the AsyncAPI spec file. I'm referring to the same AsyncAPI spec, maybe which other services are also looking up, right, as to how to interact with this order service. So, and for that order service specification to be maintained in the the most pristine shape and make sure that everyone agrees on it, the best process is to make sure that there is a pull request in order for every change that goes in. That gives us several advantages. Of course, you can run your favorite linter to make sure it meets your organizational standards in terms of the naming conventions and more, etc. And then you can do something interesting, which is backward compatibility testing, which is again a concept which is based on what we already looked at, which is if you're able to take an API specification and run it as a test as well as a stub, which means I could take a newer version of the API specification, run it as a stub or a mock, and take the older version, run it as a test against that particular stub or a mock. And if the tests pass, then you know that the changes you're making to that API specification are backward compatible. If tests fail, there is a breaking change going on. Now this is beautiful, right? Because as a group, we come together, make this API specification change, and then we try to push that into the pull request, and then we realize that, hey, we might be making a breaking change without ever having written a single line of code on any of the applications, purely based on your API specification. We get that feedback right now, and then we can take a decision as to if we should make that change in a backward compatible manner, or maybe do a version bump. So that's useful feedback again. I don't have the time to get into that, but if you're interested, you can always look up this particular topic, and we have very many other sources where we have spoken at length about how we can achieve this. But this is super interesting because at this point, at API design phase itself, we are able to identify breaking changes, and that is a complete shift left. And once that is done, of course, there would be a review by a committee of people who are guardians or custodians of that API design and specification. And once it is in the source of truth, you know that we can pick it up using Specmatic, like I showed you in the specmatic.yaml. API consumers can use it as a mock, API providers can use it as a test, and again, in an async scenario, it depends on which direction you're looking at it from. And of course, with these tests and stubs, not only are they going to be able to run on your local machine like I showed you, you can also run them in your CI, because practically the Specmatic and also in this case when I showed you Google PubSub, that's also an emulator. You can run them completely in your CI without having to depend on a deployed environment. So if I can run stubs and contract tests in my local and in my CI, so far you see that both the consumer and the provider teams are independently making progress without ever having to integration test with each other so far. But that said, the guarantees remain in the fact that Specmatic is making sure both sides of this coin, or rather both sides of this API specification, are adhering to the spec, and thereby adhering to the agreement that we all achieved during the API design stage in the beginning, right? Now this means you have complete peace of mind when you deploy the various components to your integration testing environment, and you're not going to have any surprises now. It is just going to work because most of the issues would have been caught much earlier in terms of at least the contract compatibility, which means you have a smooth path to production. And with that, we have shifted left the identification of compatibility issues all the way to the left. It gives a great developer experience, and again, you don't have to take my word for it. You saw how useful it is for a developer to be able to see when I'm making a mistake, as I'm making it, live feedback, without having to wait for it to blow up in a higher environment and me getting that feedback much later, which avoids the context switch, right? And for me as a developer, the biggest and most important aspect is to avoid context switch. That's very, very expensive. So anything that helps with it is really, really important. And of course, all this means reduced time to market, and parallel development means you can ship features much faster, because all service teams can make independent progress as long as we've agreed on what the boundaries are, and those API boundaries are captured in API specification. We all have their safety net in terms of leveraging that API specification to help us move forward from there. And of course, this means we are building API resilient API building blocks, which of course results in resilient overall products, right? Which we are delivering as an experience to end users. So with that, I thank you for your patience. Again, my name is Krishnan, and these are my contact details. I'd love to hear your feedback and thoughts on what you thought about the content presented. Thank you again.